This tutorial demonstrates how to train a random forest classifier using scikit-learn. The data we use in this example comes from the QSAR group's biodegradation database as hosted on Kaggle. The dataset consists of over 1,000 molecules alongside 41 unique descriptors. The goal of the problem is to predict whether a molecule is biodegradable or not. For convenience, we have gently pre-processed the dataset to encode its class labels as 0 and 1. The dataset is available for download using the link in the description. In order to upload training data, we first click the Dropbox button in the left sidebar. This will bring us to the Dropbox page. We can then click the Upload button. Then, when the browser's upload window appears, we navigate to where we downloaded the file before and we select it for upload. If the upload was successful, the file will then be visible in the Dropbox. Next, we select the Bank Workflows button in the left sidebar, which brings us to the Bank Workflows page. We then search for the Python MLTrain classification workflow owned by the curator's account and copy it to our account. Next, we can create a new job by selecting the Create Job button in the left sidebar. This will bring us to a new job in the Job Designer page. First, we'll give the job a friendly name, such as Python ML Tutorial. Then, we'll click the Actions button and choose Select Workflow. This will bring up the Select Workflow dialog. We then search for the Python MLTrain classification workflow and select it. The Job Designer changes now that our machine learning workflow is selected. The Materials tab has now been replaced with a Dataset tab. Just as the Materials tab shows a preview of the materials the job will see, the Dataset tab shows a preview of the dataset once it is selected. To select a dataset, click the Actions button and choose Select Dataset. This will bring up a Files Explorer containing all files presently on the Dropbox. Choose the training set we uploaded earlier. A preview of the data then appears on the Dataset tab, indicating that the data has been successfully loaded. We have now chosen our machine learning workflow and training set. Select the Workflows tab and we can see our training workflow. We can see two sub-workflows available, Setup the Job and Machine Learning. The Setup the Job sub-workflow contains instructions to copy in the training data. However, a word of caution. The Setup the Job sub-workflow is automatically configured during the training process. Modifying it can disrupt creation of the predict workflow, leading to inaccurate results or a failure to generate the predict workflow. Select the machine learning sub-workflow by clicking on it. The following workflow units are now visible. Setup packages and variables. This configures the job and downloads all required packages with pip. Data input. This reads the training data from the disk. Train test split. This splits the data into a training set and a testing set. Data standardized. This scales the data such that it has mean 0 and standard deviation of 1. Model train and predict. This handles the model training and prediction. ROC curve plot. This draws a plot of the receiver operating characteristic curve. We will begin by configuring our machine learning sub-workflow. To begin, select the important settings portion of the workflow editor. Then set target column name to class to define the target column of the training set. Then set the problem category to be classification. The workflow has now been configured and we are ready to train. Click the check mark in the upper right of the Job Designer in the header menu to save the job. We now return to the Job Explorer page with the job in a pre-submission status. We can now run the job and wait for it to complete. After a few minutes, the job will complete. We can then visit the Job's Results tab, where we will see that two properties have been calculated. The first, Machine Learning Model Train and Predict, is the predict workflow that was generated by the machine learning job. The predict workflow can be used to leverage the trained model for additional predictions on new data. The second result visible is Machine Learning ROC curve plot, which contains the ROC curve we calculated to assess the model. This concludes this tutorial on training a random forest for classification using scikit-learn.